All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our malaria training cognates module. Let's have a look at what we're doing today. Now, yesterday, if you recall, we went over the process of altering our code so we can try to attempt to get our code to run a bit faster. So let's pick up where we left off. So another thing we could do to make the debugging faster is take off the validation data equal val data set. And we don't want to lose the original code like I explained yesterday. So I showed you how we changed that. And then I showed you how we changed the sigmoids to ReLUs. Then I showed you how we changed our kernel size from a 5 to 3. I also showed you how we added batch normalization. And then we ran our code. So this is the code here that we got after making those changes. And we also took yeah, that was it. I told you we took off the validation. So that's why we don't have the validation here. So as you can see, I ran it already and I left it up just in case we needed to see it. But I did print it out so you can see these are the results here. These are the three epics we trained with the Linnet model, with the reduced kernel size, with the ReLU activation, without the validation data, and the batch normalization. As you can see, our numbers still kind of fluctuating. So our first number here was a 0.0169 for our value loss for our first epic. The second value loss number was a 4.2378. And then for the third epic, we had a 1.4514 for our value loss. Now, the only thing that actually improved, you can see here that each step actually took 3 seconds to train. So each epic took exactly 3 seconds per step to train. So you can see here 3 seconds for the first epic, 3 seconds per step for the second epic, and 3 seconds per step for the third epic. So I guess that actually increased when we took off the validation. That actually improved a lot as opposed to all of the other steps. Let me go back up if I can show you a quick example of those. So you can see here the last one for that epic was a 3 seconds per step, but before that it was 11 seconds per step for those two, the second and the first epic. Then on top of that we have, let me see here, 10 seconds per step, 4 seconds per step. Yeah, so it looks like it kind of is stabilized. I guess that's maybe because of the batch normalization also that helps stabilize that training process. So you can see here for all of that, everything we took off, we still have some value losses that are fluctuating wildly here. It goes from 0.1 to 4.2 back down to a 1.4. So yeah, maybe it's because of the editor I'm using, the VSC code. I'm pretty sure that doesn't really matter because data is data. It should all be processed the same way. So I'm not exactly sure what's going on with that right now, but we will get to the bottom of it. But what I can say for sure is that we did get our steps per second down dramatically, and they all stabilized. So we have 3 seconds per step for every epic that we had in our last run or our last run session here. So that was that, and now we're ready to move on to the next step here. So also, let me see. Also note that the model did train quicker without the validation, with an average of 3 seconds per training step for each epic. Now we got that out the way. Now that we have compiled our new model, the next thing we are going to do is add a metrics equal accuracy to our compile parameters. So let me show you what that looks like. It's on line 155. And you can see here we originally had this line commented out, but now we have it activated, and it originally was the what was this here? This was the root mean squared loss, but now we have it set to the accuracy. So let's go back down and explain exactly what's going on with that. Okay, this will display the actual accuracy of our model's performance. So when training, we'll be able to see how the loss in accuracy will evolve. A model's accuracy is equal to the total number of times that the model predicted an output correctly divided by the total number of predictions. This means that if we have a model X, for example, and then we have a model Y, and we allow these two models to carry out, let's say, 1,000 predictions. So that's 1,000 predictions for X and 1,000 predictions for Y. Now let's say that model X does 800 correct predictions, and then its accuracy is going to be divided by 1,000. So that's going to be 800 divided by 1,000, which will give us a fraction of zero point 0.8. So model X would be training at an 80% accuracy. Now if we have model Y, which does 980 correct predictions, we would have 980 divided by 1,000, which would give us a fraction of 9.8. So Model Y would be training at a 98% accuracy. And in this case, we will see that Model Y outperforms Model X. So that's what the accuracy does. It gives us a chance to see exactly how the model is performing and its accuracy on making the correct predictions, how often it makes the correct prediction compared to how many predictions we're making as a whole. So it should be noted that the accuracy is a performance metrics. It should be noted that the accuracy as a performance metrics isn't always the best choice of performance metrics when it comes to classification problems, as others like the precision, the recall, and the F1 score, and many others exist. For now, we use the accuracy, and later on, we'll look at the other metrics which we would use when we are dealing with classification problems. So they're saying that the accuracy isn't always the best metrics to use when using the classification problem, because there are other parameters out there we can use to get a more accurate scope of how our model is performing. But for now, we're going to use the accuracy, and that's going to work just fine for what we're doing. So I'm going to go ahead and clear this out on my screen. Of course, you know I'm not going to be able to run it for you today in real time, but I can start the compilation process so it can be ready for us by tomorrow. Like I told you a few days ago, the next few days are going to be a crawl inside the TensorFlow because we have to compile everything very slowly. But yeah, so that's where we're at. I just wanted to give you a quick update. So again, to get this compiling now. So that's where we at. So I did give you the latest information with the how the model performed without the validation data and all of that other information removed, and then we batched some things up, and then we added the accuracy, but we didn't add the accuracy yet. But we batched some things up, we removed some things, and we alter some things. See, our value losses are still kind of sketchy, so hopefully we get to a solution for that. If not, I may go outside of the cost to see exactly if I can do some digging and see what's going on with that, and if I can improve the situation on my own. But we're going to keep moving forward. And of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. Oh, before we go, also, let me give you an update on what else we've been doing. I know I didn't give you an update yesterday on our math, but like I told you, every day that we do coursework, we're going to do math work. So let me see where we at with this. Where did we leave off? I think the last thing I showed you was the Jacobian chains. We started that. So that's this here, the Jacobian chain. And as you can see, we've been chipping away at it. Yeah, we've been chipping away at it. This is all Jacobian chain. I'm moving pretty fast, but let me go back up so I can show you where we started. And the last thing I showed you, we were about I think we were about here the last time I showed you our process or our progress in the Jacobian chain. But now we're around, we got through all of this. Some of this was yesterday, some of this was today. The majority was today because everything is getting quite interesting. And I did find out that we are still in the introduction. So when things actually do pick up, it's going to be quite interesting. It's going to be very in depth from what I can see. So yeah, that's where we at with our math course there. And let me go back and check and see if we started compiling now that I gave it some time. I can actually start the compiling process, and we can get through what we need. It still hasn't started compiling yet. All right, so yeah, like I said, we'll pick back up tomorrow, and I should have. Well, I'm not going to say I should. I will have the accuracy epics for us tomorrow to go through and dissect. But I will keep you guys posted every step of the way as usual. For now, this is the Python Poppy. You guys stay Gucci.